So hello everyone, welcome and thank you for joining us on this webinar today. We're very happy to have you, and I will hand it over to John, our General Europe Manager, to do the introductions. Hi John.
Thank you, Ava. Hello, good afternoon, everybody, and welcome to today's presentation live from our booth at Industrial Expo. My name is John Howard. I am the General Manager for Elmo Europe, and I have responsibility for sales, marketing, and application support throughout the UK and the EU region. I'm absolutely delighted to be joined by you guys today, as well as Elmo's sales and application specialists, who are available throughout this presentation to answer any questions you may have, either online during the webinar or afterwards via a separate call or video meeting, whatever's appropriate. Of course, as we continue to deal with the global challenges presented by COVID, traditional exhibitions and conferences are paused, meaning that we have to find different ways to reach out to our target audience and share the technology. Of course, here in the UK, we heard from Boris last night that perhaps by June we will be free, but in the meantime, we will be using platforms like Industrial Expo to be able to share with you what our company is doing. So we're really pleased to be part of the Industrial Expo conference and showing the way with our engagement and also with our technology. In the delegate pack that we provided after this session, there will be a link to our virtual booth. Please visit. Please look at some of the additional products that are showcased at the exhibition, and you can interact with us via a live chat session. Please visit, please share your experience with our colleagues and encourage them to visit too. So today's presentation is entitled Cutting Costs by Technology. It's hosted by Eva, our Sales Enablement Manager, who's based in our facility in Israel. Eva will spend the next 35 minutes or so introducing you to our motion technology and illustrating how deploying this technology in your machine designs can bring real, tangible benefits in terms of machine throughput, yield, quality, while significantly shortening the development cycle and the time to market. Over the next coming months, we will be presenting further illustrations of the core differentiators which place Elmo Motion at the forefront of motion technology, including an in-depth review of our fully certified functional safety embodied with the platinum drives, SIL, software in the loop function that allows you to embed your own custom algorithms into the core of our drives, and a further session on our green credentials and the extreme efficiencies we can achieve with our drives, eliminating EMI and other issues. So invitations to these future webinars will be presented to your inbox very shortly. During the presentation, please feel free to pop any questions in the chat window. We will pause to answer these questions as the presentation continues, as well as providing a fully interactive Q&A session at the end. Please add your email address so that we can follow up any questions after the session. And if you prefer, you can send your questions directly to the presenter or in the group chat, whatever is your preference. So thank you for joining us again. Unless there's any immediate questions, please sit back and be prepared to be amazed at a brief snapshot of Elmo's advanced motion technology. Thank you, and I hand over to Eva.
Thank you very much for this introduction, John. So once again, welcome. We're very glad to have you for this webinar. And as John stated, we will start presenting the presentation. Feel free to drop any question in the chat. We actually have our experts here present, even sales-wise and technical and application-wise. So feel free to drop any question you might have, or even stop the flow. Feel free to just open your mic and ask your question as we go. And we will hope we might answer you all the questions you have. So I will share the presentation and then we can start. Okay, so welcome to our webinar. What we would like to do here with you today, the reasons that we brought you here, is to talk about the following. What we would like to do is obviously introduce to you who is Elmo Motion Control and what are we about. Some of you, actually I recognize some names, some of you we know, some of you have worked with us, some of you we don't know yet, but hope to get more acquainted with in the future. So just introducing to you who we are and what do we do. We will talk about how today's industry can be very challenging and what are those challenges that it brings, and obviously talk about the solutions that lies here and the solutions that we can give to those challenges. Now we're very excited because we are launching our newest line of Elmo motion control products. We're very excited about it, and we will show you and introduce you to this line as well. And then we will finish off by talking slightly about smart safety, which is something that has become very big in the last few years in the world of motion control and is highly interesting, and we feature it in our newest line. So let's start. So who we are and what do we do? Basically, we are a designer and a manufacturer of motion control products. But what does that really mean? Basically, we are a manufacturer of servo drives that can fit almost any application and any demands that exist in the market. We have multi-axis motion controllers that can orchestrate the motion, and we have integrated servo motors where you have a motor with a servo drive integrated, and we deliver power supply to be able to give our clients this full solution for their application. Now, more than what we sell and what are the products that we have, we thrive to be there for our clients from the very, very early design stages and all the way to the production stages. We want to go hand in hand with you all the way so that you feel that you have the entire support that you need and that you require throughout your application. This is what we are about, giving you this kind of support that you feel you have the experts in the field that you might need throughout your project. Now, we are present in almost every industry, but we, as Elmo Motion Control, wants to be where motion is critical. Every place where there are demanding needs in terms of motion, this is where we strive to be. If it's printing, packaging, harsh environments technology, electronics, we would like to be everywhere there are very high demands, very particular demands, high accuracy, high precision motion control. This is what we do best. Now let's talk a little bit about the challenges. I think today, as machine manufacturers and everyone who just simply develops a technology, everyone wants to have the top motion technology that it can bring to his project, which means even enhancing the customer competitiveness. Everyone wants to develop the best technology that exists in the market. Everyone wants to know who is the supplier that I can bring along that would give me this edge, this technological edge that I cannot get anywhere else. And people are looking for technology that is efficient, that is fast, that is the development is fast. Development time doesn't take a few years to build it. It exists that you sometimes have to develop a technology that takes from 3 to 4 years. And having the opportunity and having the option to have very, very good technology being developed in 3 to 4 months makes a whole difference. Also, when we talk about quality and lasting reliability, we know as a servo manufacturer that we want to be where applications are motion critical. And in those places, this is where the quality needs to be the higher and where the reliability needs to be higher as well. So definitely those are challenges that every machine manufacturer and builders has to deal with in order to get the best technology that it has. And what we would like to do with you today is present to you a story about a client that has similar challenges and how motion control and servo control only was the answer to all of his challenges. So this client, we will not mention his name, but we can show you what this client does. This is a client, we really respect his privacy, and most of our clients, we do not speak of their name, we do not mention their name, because we understand how this market works and how everyone has its own IP, and we highly respect that. So we're just gonna call him the customer. This is our customer, and he definitely is a world-leading company in terms of automatic test equipment, from electronic boards to MEMS, semiconductor, very, very big in what it does. And for this specific presentation, what we're going to show you is a specific line of machine, flying probe testers, actually, that does electrical testing on boards. And we can see here exactly what the machine does. You have this video that can show you exactly what we're talking about. What we want to show you is what this line of machine that is supposed to do exactly this, what you are seeing right now with the probers just testing the boards. What were the challenges that they had? How fast did the probes need to get from one place to another? And everything that accompanied their story. So with this customer, mainly what brought him to Elmo was the fact that he was struggling with his throughput. He wanted increased throughput. This is where we're going to show you how servo performance can actually increase throughput. And there was a problem with EMI also, since probe testers do electrical testing, the environment has to be very, very clean from EMI. And this can be a challenge when you have that many electronics inside of your system. So we're going to show you again how servo performance and how good technology can solve this challenge. Another thing that he was struggling with was the machine was too big, heavy, a lot of cables. So that was a challenge as well. And the fact that the multi-axis motion control needed to orchestrate the entire motion. Now, all of this, you wrap it up with extremely fast development time. So better technology, better throughput, but he wanted this done very, very fast. He had a very short timeline in which everything needed to be done, an entire line of machines that needed to be upgraded, and those were the challenges. So what we're going to do is we're going to take you one by one and show you the power of servo performance and how servo only can be responsible for solving those challenges. So let's take you one by one. Let's talk about throughput for a second. So what you can see here, you can actually see the probe testing the board itself. Now, when we talk about throughput in such application, what we say is we want to be able to take the same period of time, but to test that much more material in the same time. This way, we have faster motion that enables us to have better throughput. This is the goal when we say throughput. And basically what this company did is that they were testing Elmo motion control technology against other competitors. And they set up in a warehouse the same machine, so this probe tester line that we're talking about, with Elmo technology inside and other competitors as well. And they ran it for a certain period of time with the same profiles, the same machine, the same requirements, and the same amount of material. And they wanted to see what were the differences between all of the suppliers. And what this test showed is that Elmo technology was faster by 23%. Now, when you take X, Y, Z synchronized motion, all of it faster by 23%, what you get is the throughput is up 23%. So we are able to get 23% more material through in the same frame of time. Now, this seems like a made-up number. This seems like it's not really logical. And what I like to show you here is how only servo performance can be in charge of improving throughput by 23%. So this is what we're going to do now. So the solution is two-sum. We're going to talk about current control and the role it has in increasing throughput, and position and velocity control. So when we take current control, what we'd like to say is basically we have a probe, it needs to get from one point to another, as you saw in the video, as fast as possible. This is the goal that we're trying to achieve. Now, when you have advanced and fast vector control algorithm, you are able to control your vectors very, very fast. This is one reason that you are able to get from one point to another in point-to-point applications. So this is the first reason why you can be faster and increase the throughput. The second would be 2000 to 1 ratio of dynamic range. Now, what exactly does that mean? Here we're talking about current resolution. We have a 2000 to 1 current resolution, which means the differences between the higher current command and the lowest current command that this server drive would be able to give is 2000 to 1 ratio. And basically what that means is that we can deal with very, very, very small corrections in terms of current signals. Obviously, this has a very big impact when we talk about throughput and we talk about the application, the probe being able to move faster and more accurately. Now, when we talk about current loop gain scheduling, we would like to address something specific, which was the DC bus voltage variations. As you all know, when you're working with a DC bus voltage, you have voltage variations. It's not always a clean cut of what you get. Sometimes there are small variations and alternation in terms of the voltage that we get. And when you have an algorithm or something that can compensate for those variations, you can make sure that no variation affects the motion. Nothing moves because the system is used and is programmed to get a certain amount of voltage. And when those variations happen, it could definitely affect the motion and its efficiency. So the motion stays precise and accurate because there is a compensation for those variations. So this is in terms of current control. What can we do in terms of current to improve what we can do in terms of current to improve the throughput and be faster? Now let's talk about position and velocity control. Well, basically, it's one thing to get very fast from one point to another and have very high acceleration rates, but it's a whole other thing to be able to settle on the right spot. And in order to be able to do that and settle very, very fast, there is an algorithm that is in charge of fast settling in point-to-point application. So basically, once you get very, very fast to one point, you want to settle very fast. So get from high acceleration to very high decelerations and then get settled as fast as possible. So this is something that enables the machine to be faster. Now, one other thing is the velocity gain scheduling, which means if you have a gain that can be adapted to be able to allow very high accelerations and to be able to adapt itself when we have very high decelerations, then everything runs smoother and faster. And you don't need to stop and make the time to adapt to those changes in the acceleration and deceleration. And in those types of application, this is critical. Now, when we say speed and position load tracking error, what we want to say is there is a very narrow window of what the customer allowed specifically for this application. He had a very tight requirement of what could be the error. And by being able to stay in that window, and actually what we did is exceeded and were able to be in a window that was much more narrow than the machine requirement were initially, were able to solve this issue. So all of this is the reason that the throughput was increased. The current control, the position and velocity control, everything is very fast, very smooth, and very accurate. And when you move that much faster, you are able to run much more material in the same time frame. So now that we've talked about the increased throughput, there is one more thing that servo performance is in charge of dealing with. And for this specific example, we'll talk about the weight system. So weight systems are very common in this type of industries. A lot of the people use it. It's basically a very thick table of granite or any other material that's very, very heavy that you put on a machine. And by that, you make sure that the machine is stable at all times. Now, by having a machine that is stable, you reduce the vibrations and any vibration that could affect the motion. Now, what was able to be achieved here is that there were vibrations. There were vibrations that needed to be taken care of, and thanks to an algorithm that can actually find the exact frequency at which the vibration occurs and put a filter specifically on it, you don't really need all of that wave system anymore. There are much less vibrations. And this is how the algorithm looks like. You have the before and the after, and you can see how much the machine is smoother. And this resulted in the fact that the granite weight table was reduced by half a ton. So you can imagine what big change it is to reduce half a ton of granite from a machine only by applying a filter, only by applying a very smart algorithm that can suppress the vibration, the specific vibration on a specific frequency. Now, I can see we have a question here. I'm going to address it with our expert, Rob and Kevin. So Gabrielle is asking, does it exist an automatic tune procedure for the gain scheduling? So I'll let Rob answer that.
Okay, yeah, good question. Basically, we run a sine sweep to estimate the characteristics of the machine, and from that we can then set up some gains. But this is either done typically at standstill, so now you only have plant data for whilst the system is at standstill. It is possible to also run a sine sweep at speed to gain more plant data, to then ask the controller to find a different set of gains at speed. And then we can ask the gain scheduling algorithm to map some gains between those two set points. So it's not an automatic procedure as such. You can just run a sine sweep at standstill to get a set of gains and ask it to estimate roughly some gains at speed, which it will do, but obviously it's an estimation without as much data. So directly, it's not a completely automatic setup, but we do have a lot of useful tools to enable us to optimize pretty much most systems. Okay, I hope that answers your question.
Yeah, thanks.
Thank you.
Thank you, Gabriel, for giving us the opportunity to talk that much about our gains and what we have. Guys, keep them coming. Please ask all of your questions. This is what we are here for. We would like to talk a lot more about you than about us. So keep them coming. So let's continue on to the next slide. What we would like to talk about here is the fact that servo performance can be in charge of reducing footprint. So as we said, we can reduce footprint by just making half a ton of granite unnecessary because we applied the necessary filter. There are no more vibration and the weight system becomes unnecessary. But there's a second way to do it. Basically, what we said is our servo drive are very efficient. We have up to 99% efficiency in power conversion because our PWM switching technology is very, very efficient. Now, this seems like a lot of slogans, so let's talk about what this really means. What this really means is due to the drive's efficiency, you actually need a lot less cooling methods. Basically, 99% efficiency means 99% of the electricity that comes in the drive actually comes out of it. This is what this means. And when you have that little heat loss, you have that little heat to dissipate on the servo drive. So when you don't have that much heat to dissipate on one servo drive, you need very, very little cooling methods. And by that, you reduce drastically the footprint of a machine, because I don't have to tell you how much space can fans take and other cooling means. So definitely, this is a drastic way to reduce the footprint. Okay, so we were talking about EMI and how EMI is important because we are here in prop testers that do electronical testing. So in electric testing, when you have EMI in the environment, this could affect the quality of your tests. And this could affect your ability to test as well, So you need as clean as possible environment from electromagnetical interference and any unwanted noise. So what was happening in this line of prop testers is that they had a lot of active noise filters to filter all of this noise and this EMI. But due to Elmo's very negligible EMI omittance, actually once the technology was introduced to the machine, what we can see is all of the active EMI filters that were very big and very bulky became completely unnecessary. They actually put it all away and threw it because there were no need for any EMI filters because the servo drive itself, the PWM conversion is so efficient. There's no too much need to correct the signals. So this way, there is very, very little EMI emittance. And this is very important when we talk about prop tester. This is what they want more than anything sometimes, just to have a clean EMI environment. So this is crucial, actually. Now, we've talked about the fact that there were EMI filters, the machine footprint was reduced because of server technology, because we don't need any cooling methods anymore, just little cooling methods anymore, and because we have higher throughput thanks to server technology. But let's talk about the fact that there are a lot of access here, and someone needs to orchestrate the entire motion and communicate with all of those. And this is where the multi-axis motion controller comes into the picture. So basically, there's a host, the client's host, a PC, that needs to communicate with, needs to be in charge and orchestrate the entire music. So this is what the multi-axis motion controller does. Now he communicates with all of the 24 server drive in this application through EtherCAT communication. Now let's talk a little bit about this motion controller. Basically, the Maestro that we talk about has the ability to control up to 256 axes of motion. So in this project, it controls only 24, but has the ability to go up to 256. Now, there's something that we call motion without programming. Obviously, when you get a multi-axis motion controller, you need to program it to do exactly what you need it to be and what you need it to do in your specific application. What we have is structural smart building blocks that can actually, with the help of blocks, you drag them around, you build your script, you build what you want the machine to do. And with a click of a button, all of this goes into, for example, the C++ code that is ready to go and can be downloaded on the drive, under Maestro. So this is what is very important, the fact that you can program it without having too much trouble doing so. There is obviously enhanced fieldbus support, EtherCAT. We also support CanOpen. In general, for this application, it was EtherCAT, but we support both with our Maestro. The software performance are enhanced, and the metadata transfer, which is very important when we need to communicate with the host back and forth. Now, I'd like to take you to something a little more specific in the multi-axis motion controller. So basically, we have what we call MDS, the Maestro Development Studio. This is where all of the motion and all of the programming takes place. It is actually interfacing with the host with the help of Elmo's APIs. We have specific APIs that are Elmo's, that are built for your convenience, that you can build the program that you want. And the metadata transfer, as we said, is done this way, so you can communicate back and forth. And the networking cycle time, which is very important. This is the rate at which you can communicate, and all of the commands go through the communication, was very, very shortened by this this Maestro. So what we can see here is the host communication cycle time was reduced from 4 millisecond a message to 200 microsecond a message. So this is definitely one of the reasons the motion is faster. When you communicate faster, when you have a shorter communication cycle time, everything runs faster and you have the ability to correct yourself faster. Everything is simply going at the shorter cycle time. So we've talked about this application and what was special about it, the challenges and how they were solved. We've talked about the server drives, we've talked about the server technology. We have talked about the Maestro, the Platinum Maestro, and how it orchestrates all of this. But let's talk now about how do we do all of this. And everything starts with our software, which is the Elmo Application Studio. Now, this software, actually, I once went to a client meeting and I asked, how do you find the software? The software is where you implement your entire motion. So this is how it looks. This is how you have your filters. This is how you have your profiles. And I asked, do you need maybe additional training on the software? How does it work? Are you happy with it and the results? And basically what he said to me is, you know, there's something very important that you should know about your software. Before, when I were using your competitors, I needed a senior motion control engineering to do even very simple motion tasks in terms of implementation. But now the software is so intuitive and so flexible that I can take a junior engineer that doesn't understand a lot about your specific technology, and it just catches up and learns how to do it very, very fast. And he actually said to me, my engineers learn from motion from this software. And he was actually a team leader for AGV, a manufacturing company. And he said this software makes it very easier on them to implement the motion and to understand how to do so with the system. So this is crucial because at the end of the day, this is the interface that the engineer has with the servo drives and with the Maestro, one of the interfaces that he has with the Maestro. But this is the way to implement the motion. And the software is very, very flexible. Actually, you have on our website a lot of demos showing you how to communicate with it, how to connect your drives. And it's very interesting demos, and you're welcome to take a look at it. So to summarize everything that we've talked about through this story about this client is how the throughput can be increased, the machine footprint is reduced, how shortened development time with the ease software, the development is just shorter. The development time is simply shorter. Everything runs shorter because everything is so intuitive and easy to do. Now that we've talked about this story, this client, his success, his challenges, and his solution, let's talk a little bit about who we are and what we do. So we are a company with the headquarters based in Israel. This is where the designing, the manufacturing, the distribution takes place. We have manufacturing facilities in Israel as well as in Europe, and we have worldwide offices in almost every continent where we have points for support, for sales, and that are very active. And actually, all of our European representatives are here in this meeting. Now, let's talk about the fact that we have over 70 R&D engineers working for this company in the R&D department, because this is only to show you how much emphasis do we put on technology and how we believe that technology is the best thing that we have to offer. We have experts working on understanding trends and technology and where it is taking us and developing our technology according to the most higher and most advanced developments that there are. Now, let's show you the lines of servo drives that we have. So it starts with a Simplake line that we have. We've had it for a long time, and we see how reliable it is. It is implemented in almost every industry. We have servo drives implemented for 15 years that are working without any issues, and you can see that the servo drive is highly, highly reliable. Then we go into the Gold line, which is basically a line that fits almost every need that exists in the market today. It is smart servo functionality for very demanding applications, and it is one of our greatest lines. Now, we are very, very excited to launch together with you our Platinum line of servo drive, which is our newest line, where as we speak, we're launching it. And what's special about this line is basically there is enhanced servo performance, so even better than all of the great servo performance we had so far and we've talked about in this application. We have the ability for one servo drive to serve as a multi-axis controller as well. I'll give you an example. If you can see, my mouse is actually standing on our Platinum Quartet. This is one servo drive that actually is made of 4 separate and individual servo drives in one package, as we have one multi-axis motion controller inside of this package as well. So with this package, which is something like this size, like a block of butter, you have inside 4 independent servo drive plus 1 motion controller, and actually this product could be perfect for AGVs, for example, where you need 4 axes for traction, for example, and 1 motion controller to orchestrate all of those 4 wheels. It can be very classic for other application as well. This is a product that we're very proud of. It is one of its kind and almost non-existent in any other market that we've seen so far. 1 servo drive that are 4 independent servo drives plus 1 multi-axis controller in that small package with safety, obviously. This line features functional safety that is certified by TUV. What we have in the certification is that we are certified for functional safety. We have 8 safety functions that we're certified for so far, and we will be extending our certification in the next few months and having the second phase of the Platinum line with a more extensive choice of function and of safety function. There is safe IO support, so we have a dedicated board on the servo drive itself that is dedicated to support safe IOs and is certified by TUV as well. There is FSOE, which is safety over EtherCAT. It is revolutionary to have one communication channel, which is the EtherCAT, now being able to deliver all of the data that is safety related with the same communication channel. And all of those have dedicated safety implementation tools inside of the software, the e-software that we have talked about. Now, to summarize everything that we've said so far, we definitely want to be safer, smarter, smaller, and faster servo. This is what we stand for. But mainly, we would like to support you with any demanding application that you have. So you are welcome to reach out to our team. I'll introduce to you the team. Actually, this is everyone that is based in Europe. We have John Howard, which spoke earlier, which is the general manager for Europe. We have Stefan, which is here as well, managing director of Austria and Germany. Hi, Stefan. We have Christian, Germany as well, the regional sales manager. We have Craig, which is based in UK and takes care of Switzerland as well. He's the regional sales manager of both. We have Adam. Hi, Adam, which is the regional sales manager of UK and Europe. And we have Simone, which is the regional sales manager in Italy. So as you can see, we have support throughout Europe. This is the contact info. We've dropped it in the chat, so you can open the chat and download this specific slide with the contact info of everyone. And we would like to thank you for attending this webinar. It was a pleasure having you. I hope you discovered new things that you didn't know about Elmo Motion Control, what we can do for you. Basically, what we would like to do with you now is have an open discussion Q&A session. We would like to answer all of your questions. Some were asked already in the chat, but now you might have more questions than we have. You can consult with us on a specific application. Whatever you feel like, we have all of our experts in sales and in technical and in application as well. So we're all listening to your questions. Feel free to throw them around. We're here. Okay, so we have a question here. We have Adrian asking, does Elmo offer high voltage drive with integrated functional safety too? So this one's for Rob. I'll let the expert answer.
Okay, thank you for that. Currently, we don't have a high voltage platinum drive. We do have early versions available, but they're not quite ready for full scale sale yet. But next quarter for general release.
So thank you, Adrian, for this question. Come on, guys. What other questions do you have? You're welcome, Adrian. Okay, we have another question. What does dynamic range of 2000 to 1 mean, and how does that benefit the performance of my machine? Well, that's a very, very good question, and I'm very happy you asked about it. I'll try to explain a little further, or maybe I'll let Rob explain this. Okay,
Yep,
Rob, to you.
Yep, okay, thank you. Yeah, basically the dynamic range is, should we say, the range of currents we can detect and react to. So the wider the range, the smaller the amount of current we can put into the motor to control the positioning or to control the motion. So effectively, this is just an indication of the fine levels of current control that we can implement on the system. So it's a bit of a difficult thing for manufacturers to put into real context of what that actually means for you. But effectively, if you're trying to hold a very accurate position on a system, the higher the bandwidth or the more the dynamic range you have, the bigger this number, the small amount of current you have control over in your system, meaning it's more stable when you come to try and hold in a steady state position. I hope that explains it for you.
Thank you very much, Rob. You actually explained it way better than I did. I will explain it that way next time I present this slide.
Okay.
So does this reduce heating? Oh, great question.
Does it reduce what? Sorry, you say that again? Heating.
Heat.
Heating.
Yes.
To some degree, it will help. I wouldn't say it was a big factor. Being able to select the correct gains at the correct speeds and analyze the system so it's set up efficiently has probably a bigger effect on heating. So if it's overall heat generation, one of the bigger areas, more than the current resolution that we save in, is the actual hardware switching technology. And it's because of this overall, or this great efficiency, is the only reason we can make drives as small as we can make them. So yes, it helps, but it's not the key factor.
Thank you very much for this question, Adrian. This is actually a good question because it is important to understand the relationship that we have with heat in terms of each feature. So thank you very much. Does anyone has another question? As you see, we have our experts here. So feel free to throw anything you have at us. Well, I see that there are no more questions. Oh, there is, Francesco. Thank you. Do you support even AC induction motors? Great question. I'll have Rob answer.
Okay, so AC induction motors currently aren't supported, unfortunately. It's something I think, well, hopefully we will do in the future, but not right today. It's effectively inside the drive, it's a different algorithm, so we pretty much work with the high-end performance applications, which are typically permanent magnet.
No, thank you, Francesco, for your questions. Come on, I'm sure there was more. So you should know that if you have any other additional question, you can send it to any of the contacts that we have. There are email addresses for all of our regional sales manager for Europe. So feel free to email them with any further question you might have. Our website is available as well. We would like to thank you very much for attending this webinar and for taking the time to hear about Elmo motion control. We really hope to be in touch soon and to have you reach out and get a chance to talk to all of you. Please visit our booth at Industry Expo. And well, thank you. And we'll hope to see you soon. Goodbye, everyone.
Thanks, Eva, and thank you everybody for participating. We look forward to speaking to you again in the very near future. Thank you. Bye-bye.